Hey guys, hoping all is well with everybody. In this video, I wanted to show you guys a very common Calculus 2 problem that can cause a lot of uneasiness and anxiety of a lot of students. And the reason for that is because it has a very good way of making it seem a lot easier than it really is. This is the integral x to the fourth minus 5x cubed plus 6x squared minus 18 over the quantity x cubed minus 3x squared dx. Now, the reason that it looks so easier than it really is because a student will look at it and be like, boom, it's a rational expression, partial fractions decomposition. And that is the right method and technique that we need to use here. You can pretty much eliminate integration by parts and exponentials because they're not going to be really helpful to us here. The reason that this problem makes itself look easier than it is because a lot of students glance by the fact that this polynomial has a degree that is higher in the numerator and then in the denominator. And that's our big problem. It's an elephant in the room practically. Because in order for a partial fractions decomposition to work, we can't have a denominator that is lower in degree than the numerator. So you're probably asking yourself, well, how do we get around that? Well, basically, you have to do some hocus pocus mumbo jumbo that is going to allow this expression to be expressed in a different way than how it already is. Now, spoiler alert, as you guys can probably tell, remember from a long time ago you guys learned about how in algebra you're not only restricted to doing long division of numbers, but you can also do algebraic expressions and that polynomial division, and you thought you would never probably see it again? Well, I'm going to tell you right now, this is probably one of the most beneficial and advantageous times to use it. And the reason that is, as you guys can see from the remainder of negative 18 over, again, remember, when you do a remainder with polynomial division, you have your value that is left over your original divisor. Do you guys notice how this equation, or this expression right here, is a rational expression where the denominator has a higher degree than the numerator? That is where we're going to really benefit from the long division. This now becomes this. X minus 2 minus 18 over x cubed minus 3x squared. Now, what I'm going to call your attention to is, remember, this is still an integral. But because of this sign right here, I can make this two integrals, and that is awesome because it's going to make my life a whole lot easier. So I'm going to represent this as minus the integral of 18 over x cubed minus 3x squared. Now, these two integrals have become a lot more simpler from this big, bulky, big man on campus guy up here. This one's not bad. This one's just powerful. But remember, guys, I want to stress to you, please don't forget your differentials. They are extremely important. Okay? But again, this is just powerful, and this guy right here is going to be our partial fractions decomposition. Okay? So let's go ahead and do that decomposition. Remember, when we have a partial fractions decomposition, our overall goal is to make the factored form of the denominator into partial fractions to make it much more easier to integrate by making it a set of, again, partial fractions with several unknowns. So what we're going to do is we have x cubed minus 3x squared. I'm going to fully factor this guy, so this is going to be 18, greatest common factor is x squared times the quantity x minus 3. I'm going to go one step further, guys, and factor out this guy right here. So this is x times x minus 3. And the reason I want to do that is because when we set up our partial fractions decomposition, it's going to be such as this. You have a, which is your first partial fraction, and it's going to be over x. Then you have plus b, which is going to be over x squared. So this first x accounts for the first degree in the x squared itself. And then you have plus c, which is going to be over x minus 3. So we now have fully accounted for all of the degrees of the binomial in the denominator. Now, with the next part, it gets really daunting for a lot of students because a lot of simple mistakes can be made here. But your next goal is going to basically be multiplying both sides of that equation by your denominator. So what you're going to do is you're going to multiply 18 and this expression here by x cubed minus 3x squared. And you're going to also multiply it by that other side of the equation, but I'm going to write that down here. But on this side of the equation is just everything is going to cancel out. Regardless of its factored form, this is going to cancel with this. So we have 18 is equal to a over x plus b over x squared plus c over x minus 3 times the quantity x cubed minus 3x squared. Now, this is going to also cancel stuff on the bottom, but in order to do that, we have to account for what is going to be left on the top and multiplied by the 3 unknowns. Remember, there's one unknown for each partial fraction. So we have 18 is equal to a. Basically, you're asking yourself, from this factored form, what's missing? So we have accounted for an x, so we need to account for what is left. We have another x left over and x minus 3. So you can compare. This is why it really helps to fully factor in the very beginning. Then you have b. We already have x squared accounted for, so all that's left is x minus 3. And then we have plus c. We have x minus 3 already accounted for, so now we just need x squared. And I'm just going to interpret that as x squared. So now this is all going to cancel out with this. Now that we've done this, now it's just a linear equation, which is awesome. Because now what we're going to do is we're going to solve for these 3 unknowns by using numbers that we can determine as friendly in order to cancel others out. So there's a couple tricks that I have for you guys in terms of deciding your numbers. First of all, 0 is always a great candidate. Not in every single situation, but for the majority. Another value that would be helpful is if you have a linear expression here, like x minus some value, choose that value, because you're going to also get stuff that cancels out. So I'll choose 3. And another friendly number most of the time is 1. So basically now you're going to just do some plugging and chugging to kind of get rid of stuff and cancel some things out to solve for your 3 unknowns. So we have a times 0 times 0 minus 3 plus b times 0 minus 3 plus c times 0 squared. As I am a man of my word, anything times 0 is 0. That's why it's a great candidate to choose. Now we just have b left all by itself. 0 minus 3 is negative 3. Negative 3b is equal to 18. Remember, this whole thing is equal to this side of the equation. So we just solve for b, which is going to be negative 18 over 3. b is equal to negative 6. Same thing with the next one. I'm going to explain why I chose 1 to do last, but we'll do a times 3 minus 3 plus b times 3 minus 3 plus c times, I'm going to go ahead and do the square of 3, which is 9. But again, it cancels out stuff, so that's why that second technique of choosing the intercept of a linear expression like this is helpful as well. This cancels and this cancels. 9c is equal to 18. Just do the division there. C is going to be equal to 2. And now we have this 1. The reason that I chose 1 last is because when we plug this in, basically nothing is going to cancel. But since I know what b and c are, I can plug them in. And now I'm only dealing with 1 unknown instead of 2. So we have negative 6 times 1 minus 3 plus c times 1 squared. Okay, so a times 1 is a times negative 2. 1 minus 3 is negative 2, so negative 2a. Negative 6 times 1 minus 3 is negative 2. Negative 2 times negative 6 is plus 12. Plus c, c is 2. Plus 2 times 1 squared. 1 squared is 1 times 2 plus 2. So we have negative 2a plus 14 equals, again, all equal to 18. subtract 14 from both sides. Negative 2a is equal to 4. Divide both sides by negative 2. A is equal to negative 2. Okay, so now that we've solved for our variables, now we can go back to our original integral. So now we can represent the integral into much simpler subintegrals that'll help us to solve this a little bit more easily. So we have x minus 2 dx, remember don't forget your differentials guys, minus, that's going to be extremely important here, minus your negative 2 over x minus 6 over x squared plus 2 over x minus 3 dx. Okay, so again, this first one is just power rule. So we have this is going to be equal to x to the first, raise the power up by 1, you get x squared, divide by the new power, so that's x squared over 2, minus the integral of any constant is going to be its linear expression, which is going to be, this is like negative 2 times x to the 0, because x to the 0 is just 1. So raise the power up, you get x to the first over 1, minus, please keep that in mind, it's very important. Think about this negative sign as a distribution of these next three rational expressions. So you have negative 2 over x. So this is negative 2 times negative 1. This is going to be plus of a constant. The integral of 1 over x is the natural log. So this is going to be 2, because this is just a constant, natural log of x. Remember, you always want to put that in brackets. This one's a little tricky. So this is going to be a power rule. It's going to be negative 6 times x to the negative square. So it's going to be x to the negative 2. You're going to take the new exponent, because we're going to add 1, that's going to be x to the negative 1. So that's going to be x in our denominator. And then negative 6 times the original the new exponent, which is negative 1, is positive 6. But because of this negative sign, it's going to be negative 6. Last but not least, we have 2, which is just a constant, is going to be 2 times this negative is going to be negative 2. And again, just times the natural log, this is a linear expression, so this is going to be 2 times the natural log of x minus 3. And last but not least, guys, after all of that is said and done, do not forget your constant of integration, as this is an indefinite integral. So your final answer is going to be that the integral of x to the 4th minus 5x cubed plus 6x squared minus 18 over the quantity x cubed minus 3x squared dx is going to be equal to x squared over 2, or 1/2 x squared, minus 2x plus 2 natural log of x minus 6 over x minus 2 natural log of x minus 3 plus your constant of integration. Okay? If you guys have any questions about this at all, please do not hesitate to message me. I know it has a lot of parts. If you have any questions about the long division, I'm more than happy to kind of go over that stuff with you guys as well. But I hope this does help you guys a little bit, and I hope it brings some a little bit less anxiety and uneasiness to this type of problem. But if you guys again have any questions, please don't hesitate to reach out. And thank you guys so much for watching. Please take good care of yourselves. Thank you.